Hey everyone, it's Miss Davis. Today we're going to do our Chapter 7.1 and 7.2 notes today, okay? So just a little extra, but not much. Alright, so today what I'm going to do, I'm going to show you some things. I want you to pause me, write them down, and then come back to me, okay? The first one being the I will statement, alright? Normally you do this as soon as you get in class and write the I will on your notes, but today we're going to go ahead and get it done. It says, I will set up proportions and ratios to solve for variables and analyze similar polygons. Okay, so I want you to pause the video and write that down and then come back to me. Alright, now what we're going to do are 3 of the vocabulary words that I really need you to have down, okay? So you can go ahead once again and pause me at this point, write these down real quickly, and then come back and we'll talk about them. Alright, ratio is a comparison using fractions. I know you've seen this many times and heard all about it, but I want to bring up one that I know you're familiar with, which is the slope. It is a comparison of the rise over the run on your graph. So ratio is one word that you need to know. The next one is proportions. Proportions is an equation stating that 2 ratios are equal. Okay, so one ratio is just one fraction. Proportions is comparing 2 fractions or 2 ratios. All right. For instance, 4/6 equals 2/3. If I were to cut a pizza into 6 small pieces and take 4 of them, I could feed 4 people. But if I cut a pizza into 3 bigger pieces and I take 2 of them, I can feed 2 people more pizza, but basically I've pulled out the exact same amount. I have the same amount left. Okay, so that's proportions. All right? Cross products. You've seen this plenty of times, and you've done cross multiplying for a long time, and that's basically what you're doing. But we want to make sure that you understand that cross products is talking about a relationship in proportions. So here, A to B is the same thing as C to D, just like 4/6 is the same thing as 2/3. Okay? Cross multiplying, you get this. Writing them out, this is another way that you may or may not have seen proportions written. Here, just like A to B, so the top letters on the left, bottom letter on the right, is to C to D. When you write them correctly, the letters or numbers in the middle are your means, and the letters or numbers on the outside are your extremes. Okay? All right, we're almost done with 7.1. I want to show you a couple examples, and then we'll move to 7.2. The first one is this. I want you to pause the video again and write this down real quickly. All right, example 1 says ratio of an angle measure in a triangle is 2 to 3 to 4. The question is, what is the measure of the smallest angle? All right, so I want us to think about this, okay? Earlier when we did aspect ratios talking about TVs, we just plugged in x's and equaled it to, in that time, was the diagonal of the TV because we were doing Pythagorean theorem. Well, here we know what the angles are supposed to add up to in a triangle, which is 180. So we're going to do the same thing. We're going to add x's. 2x plus 3x plus 4x, all the angles, is equal to 180. We're going to solve the equation down where 9x equals 180 and divide by 9, so x equals 20. Now, does this answer our question? Is x the smallest angle? The answer is no. 2x is the smallest angle, so we have to plug it in. So 40 degrees is our answer to that. Okay? All right, and this next problem, I'm going to show it to you, but I'm not going to solve it. I want you to do it on your own and bring it to class tomorrow. Okay? So go ahead and pause me and write this down, and then we will start section 7.2. All right, everybody, let's start section 7.2. I'm now moving to the left side of my comp book. If you started here, just move to the other side, okay? You need to go ahead and put your title, which is 7.2, Ratios and Similar Figures. All right? This is where we're going to use that little piece of paper that you picked up from your teacher in class yesterday or whenever you got it. You just need to fold it in half, okay, so that you end up with something like this. Don't fold it lengthwise. Fold it, I think somebody said hamburger-wise. Okay, hamburger. And then I need you to, we're going to tape it in a second, but first I need you to copy some stuff down. So the very first thing, I've already filled mine out, so I'm just going to trade this out. Right now you can go ahead and pause the video and write this down and come back and we'll talk about it. All right, here we go. It says that two polygons are similar. Notice I underlined similar. They're not congruent like before. They're similar. Two polygons are similar polygons if and only if their corresponding angles are congruent and their corresponding sides are proportional. So before, both angles and sides were congruent. Now, just the angles are congruent and equal, but the corresponding sides are proportional. This last little thing is just a reminder that you must compare apples to apples. You have to have the same shapes in order to see if they are similar polygons. You can't compare a square and a triangle, obviously. All right. Now, for the inside, I have one example I want you to go ahead and write down. So pause the video again and write this one down and come back to me and we'll work it out together. All right, here we go. We have, I'm going to move some things out of the way. There we go. We have this problem. Now, I want to walk you through this. This is a similarity statement. Do you remember how we had our congruency statements? Okay? It was the same thing, but in the middle you actually had this congruent sign. Well, I want you to look at something. What's missing from here to here? The equals part, right? So, because these are no longer equal congruent triangles, they are only similar. Well, we read this the exact same way we read our congruency statements, where each of the angles match up. The angles all have to be exactly the same, hence the exact same arc marks, okay? And our sides, we're going to match them up the same way too, but our sides are proportional. They are not congruent to each other, okay? So let's just start here. We're going to do the first sides, A, B to D, E. So I'm going to write that down, okay? A, B to D, E, and let's put in the numbers that go with them. A, B is 6, D, E is 3, and what does that reduce to? 2. Okay? We have to make sure they're all going to reduce to the exact same number in order to be proportional. Then we do the second two letters. So B, C, I guess I'll do that here. B, C to E, F. Okay, and that would be 9 over EF is 4.5. And when I simplify that down, I also get 2. All right, good so far. Let's try that last side. You must always do all three sides, at least in a triangle, or all the sides in a different polygon. So we've done the first two, the last two. Now we do the first and last. So now we have AC to DF. Okay, AC is 10, DF is 5, and that does reduce down to 2. So we can check those all off that they are the same, and we do indeed have similar polygons. Okay? Tomorrow in class we'll do a couple more examples of this. You'll need to show that you did finish the other example from 7.1 when you come in, okay? Have a wonderful day, guys, and as always, have fun doing your math.